Hello.
Hi. Yes.
Hi, should I call you Gaurav here?
Yeah, sure.
Okay.
You can just wait for a few minutes for people to join. In the meantime, if
All
I have
right.
any questions, you can ask them. Yeah.
I do have questions.
Mhm.
Uh, so this is my first TA session. Can I ask questions from previous, like earlier weeks also?
Yeah, sure.
Okay. The first one is singleton. There was a term singleton.
Singleton.
It is like something related to copy constructor.
Okay. I see. Mhm. Essentially, it is like it's in comes from object-oriented programming. Essentially,
Mm-hmm.
you can only have one instance or one object of it at a time. So
Mm-hmm.
normally, what happens is we have a class, so which is like a blueprint, right? Um,
Yes.
so we make a object of it, and
Mm-hmm.
so let's say there is a complex class, complex number class. So if we want a specific complex number, that will be one object of it. Another complex number, another complex number, which is another object, right? So can have multiple objects, uh, multiple instances of that class. So, but for a singleton set, you can only have one. As far as I understand, that is what it
Okay.
means.
So I can
And
only create a single instance of that class.
yeah, that's what is the property of that singleton class.
Okay, okay. The next is uh, the week 6 abstract base class. There was a error I was getting that instantiate. I can't instantiate abstract base class more than once.
Abstract base class more than once. Okay, is that a code or question? I mean, as in, if you're
It's an error. I was getting this error while solving the week 6 assignment questions.
okay, assignments normally, I mean, I don't set them, so I have no idea what the questions are. But
Okay.
if you can tell me the code or something and maybe point out the error or something like that.
Can I show you directly the assignment questions?
Yeah, sure. I don't know if I'm supposed to tell you the answers, but I can help you with the doubts or something
Okay,
maybe.
like
Yeah.
I have completed the answer, but I am getting an error. I don't. You can if you can help me, please.
Okay.
Screen share, right? Where is screen share?
Okay. I don't think you can try it. I don't know if you can share
Yeah,
your
I
screen.
can't.
Can't. Okay. You can just put your code in the chat.
Wait, I think I need to join from a logged in account. Oh, now I have access to chat. So this was the question.
Okay.
This is the complete question, and I did this. I made changes in line 1, line 2, and line 3.
Okay. Right, there is a derived class and a wrapper class. Ah, okay. Takes the base class. And then the derived class, destructor. Okay. Ah, I see. So does the compiler tell you which line it is? I think I know
Yeah,
which one.
it's
It's line with base star t equals to new, right?
wait, the compiler. Yeah, exactly.
Yeah. So actually the problem here is that the data type of t is base pointer, right?
Yes. Yeah.
So you have to use, so because derived class t is a derived class from base, so
Hmm.
you have to um, first instantiate a base pointer object using new.
Base pointer object.
Yep.
Mm,
So there are, okay, I'm not entirely sure what the question asks,
wait,
but
I can help with what are the edits I need to make. I have that.
yeah. So there are some modern features in C++. At least this is what we do in like in my research also. Like when we write code, we create so we use smart pointers. So this since this is a pointer here, base pointer, right? So we use smart pointers and pass the base class to the base class. We create a smart pointer which adds a pointer for the base class and pass
Hmm.
the
Derived
um,
class.
derived class to it. Yeah,
Yes.
to create the unique pointer or
Hmm.
shared pointer or whatever.
So what I have done is मतलब इसमें दिक्कत दिक्कत
Mhm.
क्या है उसमें?
Oh no, so problem ये है कि when you do new derived, right? So that is
Hmm.
its data type is derived pointer.
Hmm.
And base pointer you can't मतलब how do I put it? It has to be base pointer or something like that.
If I put a base pointer at the in the place of derived, how would I access the that function?
So mm, it has to be an object of derived also. Yeah.
Hmm.
Derived has, yeah, it's constructor takes a string C. It has pure virtual function and then this. Mm. I guess that is the question. You have to make two objects. I mean, ideally there will be like two objects. One is
Hmm.
the object of derived class, another is the object
Hmm.
of base class. and then you are um, using the derived class to access the base class functions. Probably there is, I think, fun defined in that. Um, no, fun is defined in the derived class. So, okay, yeah. So to access that one, and then there is a wrapper class which starts with wrapper, defines this, and then accesses t. Yeah. Okay. Actually, saying anything more than I will be giving the answer, so I can't do that. But then uh, you sort of have to figure. I think that is the crux of the question anyway. You have to sort of figure out how to use the derived pointer, as in the base star t pointer, to access the function inside the derived class. Yeah.
All right. Or last single out. What are the
Mm.
properties of abstract base class?
So the way they work is mm, like virtual class and abstract class. So
Yeah.
they're also like sort of similar to having a base class, as in we have base and derived class, parent class and child class.
Hmm.
Pretty much the same. But the difference is that the functions themselves are like they sort of don't exist as in virtual. Um, they sort of are replacement, as in they are just idle, as in they're sort of like it's like blueprint.
Just like a prototype.
They're like a prototype, yeah. They're, and the derived classes define them actually. So using the base class,
Your audio is not clear.
hello, can you hear me?
Yeah, yeah, we can now.
Okay, yeah. So yeah, like I was saying is yeah. So it's sort of like a template, I mean blueprint, where using the base class, you can access those functions. And let's say that base class has been defined for some certain specific derived class. I mean, for specific instance. So then you can access that specific function inside that class, because
Hmm.
that um, derived class has been derived from this base class. You can use sort of the same base class and its function to call all the names, but the function will depend on the actual derived class's body, like that. Yeah.
Got it. And what are the conditions that should have been met to call a class a abstract base class?
So main thing is that, like usual, you have a base class and a derived class. So base
Hmm.
class, let's say, has certain things defined. So for example, a virtual, you see virtual void function or something that has to
Hmm.
be defined in the derived classes. That's all.
Okay. Okay. That's all.
The
Thank you.
derived class can have, yeah, yeah. Derived class can have more things, but those things have to be necessarily be there. Yeah, that's all.
Okay. Got it.
Um,
Sir, can you hear me?
yeah, yeah.
Yes, sir. Good
Hi,
evening, sir.
good evening.
Actually, I'm actually from non CSE guy, like a non-programming guy. So I have taken this course so
Sure.
that I'll be having some like knowledge and
Mhm.
thankful to NPTEL. And like actually,
Mhm.
this is my
Yeah.
first session. I'm attending this live problem solving session. But anyhow, the
Okay.
course and assignment was fine. But the thing is, sir, so as I'm a Navy, what can I say, a Navy participant or a Navy learner. So
Mhm.
up to the seventh week, whatever the videos I have seen,
Okay.
I'm able to write. I'm not able to write code by my own, but like if I see the code, I can understand. If I think it should
Okay.
be there. Something is missing. So that is the
Mhm.
knowledge till there. So if we come to the
Mhm.
final exam, how many the patterns are? Will we be asked to write a code directly, or it will be similar to the assignments we are getting?
Even honestly, I'm not sure because for so actually I'm not a regular TA for for NPTEL. I'm from PMRF. So for as our requirements, I take so as for our requirements, I have to take classes. So hence these live sessions. I do not set the questions even, and I don't even know the like assignments also what that is taken care of by the regular TAs. Uh, So even I'm not sure what will be the questions and how the pattern and everything
Okay.
they're going to ask. What I can say is probably you can probably take like maybe it will be the similar pattern as assignment is what one thing you can think of, but even I'm not sure. What I would suggest is if you are able to follow code, as in if it's written and you're able to follow the logic and all, that is a very good first step if you're beginning to learn, because that that's like you can think of like that's the first thing you should be able to do while reading a code. If you are trying to, if you can understand what each line means and which function or which thing is calling what and all. Uh, Writing something by yourself, yes, definitely it takes a little time to get used to things. But then again, end of the day, coding, like many things, is just about getting used to it. The syntax, the format, all the definitions and all the concepts. Again, the more you practice, the better you get at it, and more or less, end of the day, you just have to spend some more time on it. Um, More, what I would say is, even I'm also not from non-programming. I'm also from non-programming background, so it took me some time. But then again, it's because of my research and all. You just keep working on things, and you get used to them. Once you get used to things, they come naturally. So that's what I'll say. I understand for a
Yes.
semester. Yeah, for
Yeah.
a semester, it
I can
might take
understand, sir, but
little time. Yeah, it might take some time,
yes,
which normally one
yes.
doesn't have when doing a semester. You have
Yeah.
other things also, like courses and all, if you guys are still students. So yeah, I understand. But then again, that's the nature of every course. So yeah, what I would still
Uh,
suggest is
yes, sir.
keep maybe spend some more time if you can on things. Try to get, it's all about if you can accelerate the getting used to it faster. That's all.
Yes, sir. So,
Yeah.
like as you are telling that initially you are from non like coding background, like I think you can understand my situation, right?
Yeah, yeah, no, I
So
completely understand.
I
Yeah,
also believe that so as you are in research, like it's a continuous process. Like you keep
exactly.
on going with the flow, like day by day you'll
Yeah,
be improving. But we
exactly,
have
exactly.
taken it as a course,
Of course. Yeah, yeah, yeah.
so
Right.
as of now, like I'm able to score good marks in assignments and somehow so even the programming assignment. Actually, I'm scared of programming assignments. Like so if something is asked, like sometimes in the programming assignment they are like giving the task and asked to
Mm-hmm.
write. So, like
Right.
I'm just a bit scared regarding that, but rest of the thing is okay, sir. So if you
Mhm.
conduct, I'm telling you, like if you can conduct, I mean, just I'm telling it normally. So if someone can
Mhm.
conduct this in the form of a viva or oral kind of thing, then there is definitely, I'm sure that I can make it up. But because I
Sure,
don't
sure.
have a
Sure.
programming practice, sir, so just so,
Yeah,
sir,
yeah, I
where
understand. Yeah.
the exact answer for this can I post in the discussion group so that someone can help me?
For the assignments,
Yes, sir, like a pattern of the exam,
you
regarding
can
the
just
pattern
ask.
of.
Yeah, you can ask it in the forum. Yes. So forum is actually handled by another TA. Those are the regular TAs who handle the forum. They set your questions for assignments, set your questions for exams, all the rest of the regular stuff. Yeah.
Okay. Uh,
Yeah.
okay. So
I,
then,
I mostly
so
just revise things and take these live
yeah, yeah,
sessions for
yes,
exam clearing. Yeah.
yeah, that is fine, sir. I mean, subject theory point of view, it is everything okay, but
Mhm.
practical, like if you ask me to write some code, then that is an issue, as I am telling, as you can also understand.
Mhm.
Okay, anyway, sir, so let me post in the group. So what I thought is as today is the live session, I got the mail, thought of confirming you from you. So you told me to post in the group. So
You can ask any of your queries in the forum. Actually, I sort of recommend doing that because
difficulties,
yeah, sort of recommend doing that
because the
because
lectures are crystal clear.
right.
Yes,
Yeah.
sir.
Yeah. So no, what I was saying is I sort of recommend doing that because live session is like once per week. So if you have questions and in between, it's you need not wait for 1 week. You can just post in the forum, and usually somebody will try to answer if you have your queries and such. So I mean, I'm not saying don't make use of these live sessions, but
Yeah,
make
sir,
use of
definitely, sir.
everything. Yeah, yeah.
Yes, sir.
No,
Yes,
it's
sir.
in general.
Definitely,
It's
sir.
um, to everyone. Yeah.
Okay, sir. Thank you, sir. Thank you very much.
Sure, sure. All right. Any more questions, or else I guess we can start for today's.
Sir, I think you can start, sir.
Yeah, I think it's okay. I guess my screen is visible and I'm audible. So let's start.
Yes. Yes, sir.
Last week, yeah. So last week we saw something called a friend function. Essentially, it is like the idea is that the function that you want to call has access to data members of the class. So if it's public, then obviously it's accessible outside the class. But for example, here by default, so I did not put anything the type of this data, like the data variable itself. Its data type is integer, but since I did not put anything by default in C++, all these data members and functions become private. Okay, so accessing data itself outside the class is not possible, but if you have a friend class, sorry, friend function like display here, so it has to take the object, some kind of object which is of data type my class, because otherwise it can't access the data as such. It won't have the scope, right? So once you give it the scope of data, but now it can access the data member. Okay, so this code won't throw any error and it will actually compile and run perfectly. Now the thing is, to access private data members, this is a way, is what I'm saying. So having friend functions. Yeah. Next is inheritance. So this is what even is the question the in the starting of the class. So it sort of forms the base. So let's start with the base class. And so we have a base class, has private members, has public members, has protected members. Then you can have derived classes, right? Which you derive from the base class. And now the thing is, even derived classes have access to all the members of the base class, except that it cannot access the private members as usual. Public members can be accessed from anywhere. So even inside the derived classes, right? So this data 1B will throw error, but other things won't, right? The another thing to note here is that if you try to access the protected members, that is also allowed because they're derived classes can access the protected members of the base class. So then we saw example. So it's essentially like writing. You can use this arrow pointer or just data 1D. Okay, that's up to you. I mean, as in, it's up to you how you want to access this data. Like essentially these member variables of base class. So writing this, I'm not doing anything with these variables. I'm just accessing them to compile to show you that do we throw an error or not. So data 1B cannot be accessed because it's private, but 1D and 2D, which are both private and public for derived class, can be accessed. You can access the 2B, 3B, which are public and protected for base class. So they're accessible inside derived class. And in the main function, after we make objects of base class and like base class B, like so data type is base, object D, data type derived, right? And try to access the same things again. So you see that all the commented ones are the ones you can't access. Okay. So you can access data 2B because that is public, right? So from base class, you can access that. And data 2D too, because that is public. And data 2B from D, right? So this data 2B is the member of the object B. This data 2B is a member of object D through because it's also derived from the base class. Okay. So only the public members you can access outside the class as in main function, and protected and public members inside the derived class. As usual, in every class, only that class can access its private members. So data 1D and data 1B, that's all. Okay, so that's about inheritance. So we took another example of inheritance where, let's say we have a derived class D, right, and a base class B. So again, it's similar. We can access the functions f and g from the base class. So a base class itself is also a class. You can think of it like a generic class that we have, you might be familiar with when you try to learn classes. So any class can technically become a base class, right? So that's how you can, so as in base class doesn't look any different than another normal classes. So all of them can be base classes. So that, and then you have functions that you try to call from B. So B is the object of base class, right? So then when you're calling these functions, they are called from the base class. Now to see the example that derived class can also access these functions, you can call them from B too. Okay. Now it again drives home the point that derived classes have access to the base classes functions, member functions, and member variables. Well, member, how much of the member variables we saw this example. Similar thing, if the functions are private, it cannot access them. If they are protected or public, then the derived class can also access them. Okay. Again, you can't call them functions here if it is not public, right? So those things also have add one more layer of uh, filtering in a way, if you can think of. Okay, I think this is so far so good. Then we saw another example where we do something called a function overloading. So if we define a function, let's say of data type void, and func func is just the function name. This first, we will just define this function func with no inputs, and imagine there's some code inside this parenthesis. Okay, so that forms the body of this first function, which doesn't take any data type. There are another function which takes integer I, and there's some code inside the body. Okay, so you can have different code or the same code or depending on I or whatever. But the difference is that these two are, you can think of it like the name is the same, but they're different functions themselves. Okay. Similarly, float I and double I. So you can have different codes or different or not. It's completely up to you. Essentially, the idea is that the function takes different inputs, and but the name is the same. So this is a concept called function overloading. Okay, where you can call a function, and depending on the data type you pass, the corresponding function gets executed with the code. So let's say I pass an integer, it will execute the code to line, like the code to body. Okay. If it's float, then code 3. If it's double, then code 4. The it's a side thing, but essentially what happens is to keep track of these things, the name of the function gets mangled by the compiler. So there is a way it uniquely identifies which function it is calling. Okay. That's just a side note. Then, yeah, here we see an example where we put, same name, different parameters, return type doesn't matter either. Well, return type does matter. Then it's technically not for function overloading. Then you have, okay, then you might actually run into issues. Which function is it actually calling? So yeah, that normally in the parlance of C++ not called function overloading. But I guess that is called function overriding. Yeah. No, not overriding, but some other names for it. Sorry.
Okay, so it doesn't matter actually. I think I don't know actually. When it is between base class and derived class, it is overriding, right? That time it matters.
Yeah, that time it matters. But when I say overriding, I'm overriding the body of the function actually.
Right.
Yeah.
Okay.
Yep.
Thank you, sir.
So, right. Yeah. So as an example, again, as usual, we'll include the IOStream header file, then write a base class with the public qualifier. So now all these functions will be public. And that's necessary for the example to work. So now we have two functions, which are both of which are void and take integer I. But because of f and g being different names, you can then, so now I can call the corresponding function and then it will know which to call, right? So this is a very simple code where it takes an integer I and prints I for f, 2i for g. Then let's say we have a derived class with derived from some base class, so same base, right? Here, if I define f again with another body, then it's a function overriding because f with void is already defined here. Specifically, the f which takes integer I as one input as I. So all the function signatures are exactly the same. Okay, that is the important bit here. So because they're exactly the same, derived class, when you call the function from the derived class, it overrides this body of the function, overrides the existing body of the base class. Okay, so that is what is the overriding does. Then if you have a function g, okay, where I'm defining float I, and since derived class has access to base class functions, right? So you will see g here having g as taking integer I, and here it takes float I. So this becomes functional overloading as we saw here. Meaning for derived class, both definitions exist. Okay. And for integer, it uses this definition. For float, it uses this definition. Then you can just define another function h, which takes double. So it can be anything. So this is just an extra function which is allowed in derived classes. So as in whatever base class has, you can redefine them within overriding, or you can define some additional complementary functions through function overloading, or you can define new functions and add them. That's also allowed. Okay, so essentially the idea is that when you have exact same function signature, then no name collision happens, right? So to avoid that, I mean, in general, if you have functions with exact same function like signatures like this, while compilation you'll get errors. Okay, but when you're doing the same thing in a derived class from a base class, then by default the behavior is that the function gets overridden. Okay. Then we have a base. So to see all this in action, let's define a base class B as an object B from the base class and D for the derived class. Then we can just try to access b.f and pass some value. Okay, so it will call this function. You can do b.g to call this function because it's a usual class, so you can have this to access. You can then try to call d.f, d.g, and d.h. So f should use, I mean, here it depends on how the casting happens, which we will cover today. But you can think of it this way. So here it should use the overridden body. Here it should use the overloaded, or depending on the which definition we're passing, as in which parameter we're passing. So the body of that. And after that, h, anyway, there is only a single line, so it will use that. Okay. All right. Coming to today's topics, and maybe start with okay. Type passing. So we'll see some examples of typecasting. Right. So as usual, we'll include the header file IOStream to print stuff. Then let's make nothing special, just the main function. Oh, this is a question. Okay, so when we inherit the base class as a protector private, rather than using public, what actually happens? Yeah, so even I'm not entirely sure, but my thinking will go this way. Normally, when a class gets, when you instantiate an object, as in, maybe I'll go with this example. Anything actually. Let's go this one. So when we instantiate an object of a class, so it could be either the base class or the derived class, either way. Then now, first of all, the constructor gets called. Okay. And constructor, if it's not public, then it can't be called and there's no instantiation happening. So for those things, public kind of becomes necessary, right? So otherwise you won't be able to call. So if you think about it, there is, yeah, private, public, and protected. So private is only accessible within the class, right? So technically speaking, if you have a class defined inside a class, you should be able to access anything inside the private, as in, yeah, anything inside the private, right? But derived classes we make outside the class. So as in, think of like scope. So scope here is the main function. This is the minimum we can do because main has to exist in any C++ code. So in any C++ code, since main has to exist and we want to create the object, let's say here, it has to be public. In that sense, you can think of. If the class is defined inside the another class, so like let's say this is one class and I define another class 2 inside it. Technically, yes, it can access its private members. So you can probably make do with that in the sense, since derived class has access to all the members of base class, as in, except it can't access the private, but well, making a class inside it here will have sort of make it a derived class, as in you're still using all the members of the base class. So yeah, I guess you can make do with that if that case happens. But otherwise, in general, it has to be made public. Okay. Protected again, that has a special case, but I think the general idea, you get the general idea. If I want to make a class as derived, as in from like here the name is derived, but here it's a derived class from a base class, right? So to actually do that, like basically all that happens at this line. When we instantiate an object of derived class, there it has to be public, otherwise we won't be able to access it, right? So I guess that sort of gives you the gist of it. Okay.
Okay, sir.
Okay. Again, one can make a class inside another class and it will have access to all of these data members, and you can sort of get all the features of a derived class, yes, but that class won't be accessible outside anyway. So again, one can play around with this to have certain features of one class, of one thing in another thing, like that. So, okay. Right. So let's take example of some typecasting. So we'll start with integer I. So let's say this is 7. Then upload something like 5.2. Okay. Then a double T, which is, let's say, 6.7. Okay. So let's print these values. So first is I. Then F. Then P. Simple code. Nothing fancy so far. So let's print this. Okay. As expected, the output is 7. Whatever we set it to. So 7, 5.2, 6.7, so far. So on and so forth, right? Then let's do this. Okay. And then print D. So what we see is I is set to 7, right? And D is a double. So we're setting D equals to I. So D will have 7 and it prints it as 7. Okay. So this is an example of a typecasting from integer to double. Okay. And more specifically, this is an implicit typecasting. As in, this typecasting happens automatically. So this is just to complete the integer name, but anyway, you can ignore it also. So the idea is that here the I, which is integer, right? We're setting the integer value to D and an implicit cast happens from integer to double. So thing to remember here is double has higher bits. So it is a 64-bit number. So as in to represent real numbers, we use float or double. Okay. Essentially numbers which have decimal points, and then there are digits before the decimal and digits after the decimal in a base 10 representation, let's say. So to represent those numbers, we have a data type float, a data type double. Float use 4 bytes or 32 bits. Double use 8 bytes or 64 bits. This is standard in modern systems. You can have systems where this is not true, as in you can have older systems with 32-bit architecture. That's the architecture of the CPU and so on. But in modern systems with 64-bit architecture, the default behavior is that float is of 4 bytes and double is of 64 bytes. Can anybody tell me what is the type of integer? Like how many bytes then for integer?
4 bytes.
Yes, that's correct. So integer is also 4 bytes. And if you want to have a longer storage for that, you can use long. So you might have seen code with long, and so on and so forth. But essentially in systems with where the highest is 64-bit, a single long int will do. As it you just have single long and single long, like long and then int. Then the data type becomes 64-bit integer. Okay. You can have more qualifiers also. So like unsigned int, unsigned or not. After that const and all those have different properties. But the essential idea is that the storage taken up by double is higher than what's taken up by integer. So an implicit casting is all right, it's allowed, where the compiler deduces that if I convert a lower represented number, and here it's an important thing, here I is an integer being converted to double. Okay. It's actually possible that you might not be able to represent that integer exactly. As in integers, it's 4 bytes, right? So you can represent at max positive integer of 2 power 31. I think that comes out to be 2.4 billion or something like that. Now, any integer higher than that, Okay, when you try to represent in, so the idea is that, yeah. Okay, if you guys are not familiar with floating point representations, but in any case, it's just to give some context, but it's not really uh, part of this course, but just to give some context of like what is happening. Um, so when you try to represent those numbers which are greater than, so essentially till to power 31, okay, you can represent numbers exactly using 32-bit integers. So there it becomes important. Now it becomes important when you try to represent 32-bit floating point numbers. It so happens that you might not be able to represent all the integers exactly after a certain limit. Okay, so that's something to keep in mind when casting happens from integer to double. Okay, so here it is fine because such a small number, so you can have the d, which is a double, represent number 7, it's an integer exactly. So here it's okay. The next thing is, let's, if one does the same thing but this way. So here I'm explicitly saying I, and then using this brackets and giving something called a data type, or giving some data type. So here what happens is you are explicitly casting I, which, let's say here it's an integer. It could be actually any custom built data type, to a double. Okay, and then setting it to T. So it would throw error if it wasn't, if D wasn't a double data type, but here it's okay because it's double. So this is explicit casting from integer to double. So the difference is that in implicit casting, we rely on the compiler to do it for us. In explicit casting, the programmer does it themselves. Okay, it's the user managed way of doing the same thing. So if we print it now, it's 7 again. Okay. The behavior is same as in code wise, but the only difference is that here we're being more explicit. That's all. Next is doing this. Okay, so we are going the opposite way, where we're still doing an explicit casting. Okay. Sorry. But this time from a double to integer. Okay. And remember, like I described before, so double has, maybe I'll mention it here. So this also has 32 bits. Double has 64 bits. Now the important thing here is when we're casting a double D, right, from as a double to an integer, we're casting a 64-bit number to a 32-bit number. So naturally, when we cast something like this, there will be bits which will be dropped. Okay, so essentially representing a number which was using higher bits to another number which is essentially has lower bits, you can guess what happens then. You're actually having less precision then. Okay, so this is the idea here. So if we try to print I, D already has integers, right? So maybe I'll comment on no. Okay, so we casted D to be an integer. So hence you see the 0.7 being dropped. Essentially, that is what the precision I was talking about. When you're casting a number from one form to another, so let's say from one form which has higher bits to represent that number to a form which has lower bits, some of the precision will be lost. Okay. Now, here's something important you have to realize. When we think of real numbers, there are fractions which have infinite digits, right? So let's say 10 by 3. So it's 3.333 recurring, right? So technically speaking, it has infinite threes to the right, but computers have limited bits to represent. So we don't have infinite bits to represent all the numbers. Okay. So there is a system that is the floating point standard. So that essentially defines the way we want to represent numbers in, let's say, 32-bit setting or 64-bit setting, and so on and so forth. Yeah. That is also something, if you are not familiar with, you can take a look at how numbers are represented. But essentially, the idea is you lose precision when going from double to integer, like something from a higher bit to a lower bits. Okay. All right. So maybe I'll just put the precision set. Okay. So there is another thing when you're trying to print numbers, right? So using standard cout, you can actually do it this way too. Precision. I think that takes a number or something. So you can use, you can tell your output less than how much, it's a standard cout essentially, how many digits you want to print. So maybe sometimes you want to see the actual number stored in, let's say, till 10th or 11th decimal point in doubles, in the cases of doubles. You can set the precision accordingly and then see those digits. Okay. So this is just a, I think. So the smallest, maybe I shouldn't call it precision. Okay, so think of it like you can set precisions. Maybe that's better. Okay, so that is one. Second thing is the hierarchy of bits in custom defined data types. So bool is the smallest data type, then character, then short int, then integer, then unsigned integer, then long, then unsigned, then long, then float, then double, then longer. So some of the things will be seem redundant because of the 4 bytes or 8 bytes repeating. But essentially, this is the order. Okay. So from higher to lower, you lose precision. From lower to higher, you gain more precision. But then again, if the data is not there, you just fill it with unnecessary bits. But this is just a hierarchy to give you an idea of that. Okay. All right, so next example. Again, we'll include the IO stream. To define an integer I, okay, let's say that contains 5. Then define a pointer now, P, which stores the address, address of I. I talked about references and address. So as in this ampersand symbol has behavior depending on the context. So we have seen before when it's used as a parameter to a function, it's a reference usually. I mean, again, it depends on the context what it means, but there it usually is a reference. Here in this context, here the ampersand means the address. So here essentially we mean take the address of I and store it in P, where its data type is integer pointer. Okay. Ideally, I would like to write this way, where we're saying this is an integer pointer P, and this notation or this syntax here is defined such that as P stores the address. Okay, so P, since P is a pointer, it will store an address, and we're giving it the address of I. Okay. Then let's define another C-style array or this one. Okay. Oh, another thing. So here when I cast double or integer like this, so this is the C-style way of casting, typecasting. They're casting double or integer, okay, to another data type. There is a C++ way also, but their casting can be not, how do I put it? It's not so simple where here casting could mean many things, as in all of them share the same meaning. It's because it's C. In C++, you can have casting where it could be const type, or you're just casting for this instance or not. There are various ways, but well, let's see if we have time for that. But just to remember, this is the C style way of casting things. Okay, so mostly I'll just following that, but at least the concept doesn't change. Like you see, they find another double D. This time, let's say it is 8.7. Another double, okay. But this time a pointer. We'll call it, so that was P, so let's call it Q. And give it the address of D. Next, let's define a void pointer. Okay. Rather, I should write this way. Let's say call it R. And yeah, there's no need to store anything, just define a pointer. Okay, of type as void. So here it means that R is still a pointer which can store an address, but the data type it is pointing to has no data type, as in it's null type or whatever, it's void essentially. Okay. Here with P, at least it means that if it stores an address, and whatever the address is storing, whatever values, that is of integer data type. Same for Q. Q is itself a pointer, it stores an address, but the address is pointing to some number, right? The actual address holds some number. Its data type is double. And the reason to have these data types, integer or double and so on, is to know how much shift one needs to go if we start with that pointer. It's a convenient way of accessing data in a contiguous location if you know the first starting address. Essentially, that's what we do in vectors or arrays also. So if you know the starting address, we can go to the next number if you know the length of each number. So that length of each number is known from the data type of the pointer. Okay. For void, it's just not known. But again, this is a valid syntax to write. What's the use? Well, there are use cases, but it depends on the code you're writing. Sometimes you want to just pass. Okay. Yeah. Question.
Yes, sir. Is it you? Sir, am I audible?
Yeah. Yeah. Go ahead.
Okay. Sir, the void pointer is that used for functions? Because the only place where it is applicable is on functions. So
No.
does it take the address of any functions?
So there are function pointers. Yes. So it's like I think called functors. So you can pass the pointer to a function. Like let's say I have this class, right? We have seen classes and uh, member functions before. So essentially what happens is functions themselves also take some space in memory. So
Okay.
you're passing the address of that function to say some other function, or you're calling it or doing whatever. So yes, I see what you're saying. So then that function can have a void type, which happens to a lot of functions. But sometimes there are member functions which you can pass um, as in member variables, which you can pass as void.
Okay.
I don't know if you guys are familiar with CUDA programming, but there in CUDA programming, that's essentially like when you're trying to program with GPUs. So
Okay.
all these pointers and variables and everything what we are running, all of this run on CPUs. Okay. So when we want to access, but in GPUs, it also has addresses, and we try to access those addresses by passing some variables inside the corresponding GPU calls. Okay. Just a second.
Okay. Thank you, sir.
Just a second. Oh yeah. Okay. So what I was saying is, yeah. So when we try to pass those variables inside GPU functions, there we um, make them void types, because, and sometimes in cases of BLAS also, I mean, it depends. I'm not saying all BLAS, but sometimes we do, because internally those functions will decide their data type. So they take void type because they assume certain things about that address. So for example, here we know that P is storing something of integer data type, right? So if we ensure certain rules, I'm not going to more details, but if you ensure some rules are followed, you can always pass a certain, uh, so there's a certain function, all its members will always take void pointers, okay? Because it knows that every corresponding parameter is following certain rule, and then it will implicitly cast it to certain data type. It need not be these custom data types. It could be it need not be these inbuilt data types. It could be a very custom data type, okay? So I'm not going into more details, but there are use cases. Yeah,
Okay. Thanks, sir.
yeah. Right. So, right. Moving on. So let's say we write Q equal to P. Okay. Or we write P equal to Q. What do we expect? Then compile and see. If anybody wants to take an attempt also, feel free.
Sorry.
So if I run this code,
Mhm.
what do I expect? Do I get errors, or will it just run? Will it
Okay.
set a pointer P to Q, or will it set Q to P?
Okay. Okay, sir. Just 1 minute. I'll see.
Okay. Sure. I think this is more interactive also. So since people are participating today, uh, I'll give some time. Yeah, can try it out. I mean, end of the day, you can run the code for yourself and check it, and which is what I'm going to do to show you the answer. But think about it. Then again, I haven't told um, about this, but anyway, it's fine. Yeah, take a try.
It will give an error.
Yeah. Okay. Why?
The compiler implicitly can't decide if you can put P to the Q or not. We have to
Right.
explicitly tell it to do it.
Exactly. So here what's happening is typecasting is happening for pointers, which is not, it's not like it's a bad thing or anything, it's allowed, like one can actually do it. But expecting the compiler to implicitly do it, that's something compiler is not happy with. Okay. So it's not allowed implicitly. So this is again the part of the standard. It won't do it implicitly. Okay. So as you can see, there's an error. So conversion of double pointer to integer pointer, it won't do it itself. But instead of this, so let's say we don't do this. So I'll just make a remark as error. This also was an error. Okay. But instead, if we cast it, so double pointer, where's my start value? Then P. Okay. So we'll do this and switch down. P is integer. So we'll change it to integer type, the pointer, and make it Q. So these two and formats. Okay. Good question. Oh, that's fine. Now here we are explicitly casting our pointers P and Q, right? So P is of data type integer pointer. So we're casting now it to be a double pointer, okay, and Q to be integer pointer, right? This is allowed, okay, and this is something important to note. Implicit casting of pointers, okay, is not really okay for the compiler from standard also, but you can explicitly cast them. There are some very interesting things people have done with this. So again, last class I just mentioned again. If you guys are interested, you can look it up. There's a very interesting algorithm called fast inverse square root algorithm. So that uses a very clever trick of casting, essentially, like using pointers and bits, and there's some bit manipulation also. So there, one is able to calculate an inverse square root of a number quite fast. It's an approximation, but again, a very fast approximation. Okay. So yeah, explicit casting that is allowed, but you have to be careful here because you've defined P to be integer pointer, right? So its spacing is 4 bytes, and let's say it is of certain length. Let's say there is a vector we have defined of 10 of integers. So let's say there is this P holds an address, starting address of a chunk of data, like chunk of block of memory, where the total size is, let's say, 16. So if you think now Q, right? So now we are treating, so Q is treating P as a double pointer. So it will treat the 16 byte chunk with units of 8 bytes. There it is perfectly okay because you're not exceeding. So let's say you want to try it. When you try to access data, you're not going out of bounds because you're still accessing 16 bytes. But instead of 4 numbers, which were stored in like units of 4 bytes, you're accessing 2 numbers in units of 8 bytes. So that is okay. I guess you can think like you're seeing where I'm going with this. So, but if it was 620 and you try to access 3 numbers from double, then it wants 20, it will try to access 24 bytes, which the program actually doesn't have access to. That's exactly where you run into segmentation faults. So one has to be very careful while typecasting and accessing values, like dereferencing. Essentially, dereferencing is essentially accessing the values at a given address. Okay, so when you dereference pointers of any data type, and especially when you're casting them like this, be very careful. You might run into segmentation faults. Okay, here it's okay because I'm just casting and storing the address. I'm not accessing any data yet, so it's all right. That's good. All right, next. So let's make R equal to P and P equal to R. You can take a shot at it. Will this throw errors? Not throw errors? Is this okay?
So I think it will produce error.
Okay,
No,
both of them?
it's a guess. It's a guess. I haven't
Sure,
checked.
sure, sure. That's fine. There's no wrong answers. Again, anyway, this is hence I ask this more for interaction. Do you think both of them will throw error? As in line 18 and line 19, both?
Hmm.
One of them?
I actually haven't tried void ever.
Mm-hmm.
So the thing is, if void, maybe the 19th line won't give error. 18 would, because I
19
haven't
won't be.
tried
Okay.
actually.
Sure, sure.
Maybe because it is void, it may not store actually any significant bytes. So
Mm-hmm.
I think it can work,
Mm-hmm.
but I
Mm-hmm.
do not know. But the guess is maybe not.
Mm-hmm. It actually that's the motivation behind asking this question anyway, because uh, it should make you think. Okay, so I'm writing a pointer to another pointer, and the left hand side has a data type. Okay, so right hand side is also a data type, as in an integer pointer or a void pointer or whatever, right? That's actually the motivation. Let's do one thing. Anybody else wants to say something? Okay. Okay. So again, that's the motivation behind this question. So if you think about it, we are casting a p, which is integer pointer. Okay, for now, let's remove this. Okay, so fresh. Just think of this one. Here, there's no casting yet, so that will just make things confusing. For now, just think of this way. So p is the integer pointer. Okay, so we are saying that R will store a pointer p. Okay, which was integer into a void. Okay, that is allowed actually. So
Okay.
that's like saying if I had a pointer like a certain address which P already had, right? That address is now stored in R. Okay, so this is important. What do you guys think is P? As in P is a variable, yes. But what is the size of P?
4 bytes.
P is of it is of 8. It's a end pointer.
Hmm.
Huh? Sorry?
It's a pointer, so it's of 8
Sorry?
byte, right?
Mm.
Yes. So the data type of pointers is size underscore T uh, in general. So that just means that size underscore T will always point to the highest unsigned, like the maximum positive
Oh,
number it can store, your system can store. The reason for that is when we use addresses in any computer, like in RAM or anything, we number them, right? Now, if you think about it, starting with negative doesn't make any sense because we want to count. So now you're addressing will if your CPU or architecture, right, supports 64 bits. So or 8 bytes. So having 8 byte as the maximum integer you can store is the only thing that makes sense. And hence in C++, I don't know if about C, but I think maybe in C also, in C++ at least, size underscore T is the one which gets set automatically. Okay, so you can try printing size underscore T and all, but they will point to 8 bytes. So now, exactly, uh, that becomes a bit important here. P is a variable which is of 8 bytes, so it stores an address. And addresses are themselves just numbers, they're integers. Okay, they don't have anything to do with floating point numbers or anything as such. They're just integers. And now this is an address, this P, which has a value like an integer address. It will be stored in R. Okay, perfectly valid, perfectly fine. But the extra thing is that because R is a void type, here there is an implicit casting which will happen, which will say that I'm ignoring the data type of the value this address is storing. As in, P originally had P originally points to some address which is of, let's say, integer type, right? So R will just now pretend that this address that I'm getting, I don't know its type. I'm willing to forget its type, which is absolutely okay. This by C++ or the compiler, this implicit casting is absolutely okay. All right. This is what I was referring to when giving that other example about certain functions in Kubla in CUDA and so on. But yeah, essentially what happens is if you follow certain rules, then you can pass void pointers also, like what we're doing here. You can pass pointers and where it was expecting a void type, and internally that function will take care of the rest because it knows that since I've followed certain rules for the pointer to align and there are other things, it is okay with taking void pointers because it will itself then explicitly cast it or do something else. Okay. So essentially, this is okay. And let's just print it and see. So the second line is the one which will throw the error, people to R, where we are saying I had a void pointer, but now I want to treat it as integer pointer. Again, this is allowed. This is okay, which we'll see in the next line. But through implicit casting, no. Okay. So does that mean we can't do this? No, we can. We can. We just have to explicitly cast it. Okay. I think that's it. Yeah. That's okay. Yeah, my bad. All right. So the error disappears. So essentially, you can cast a void pointer to a custom data type pointer also, but one has to be careful that it has to be done explicitly. Okay. Next. Yeah. Right. One can do this also. So this is a C style array where I'm saying this is of integer data type and the variable is A, stores 10 values and each of the values are integer, right? The nice thing about this notation is that the A itself is a pointer. Okay. So doing something like this is okay because I'm storing integer pointer. I'm setting this integer pointer to have A. Okay. So this is absolutely fine. But what if I do this? What is the question? Can I pass whole object reference pointer as void pointer? Depends on the question that you ask. So when you say reference, so what happens is when you pass references, that is a whole other ball game. As in, which did we cover references? Yes, it's so here, like we see as an example, we have vectors A and C and some functions A and C, right? These functions are defined to as such. Okay. So here I have a reference of data type, standard vector, integer, etc., but then an ampersand. So here it means a reference. So A and C in individual cases. So for let's say when func A is called, so for this function, B is exactly the same as A. So when you're passing a reference, compiler treats the two objects as the same thing, as in they say share the same memory itself. A and B is just a notation we call them. Whatever A is represented as in memory, the same thing is used for B. And in the another instance of function C as in line 28, now C and B become the same because C is also passed as a reference here. So reference is different thing. Yes. So I hope the reference part is clear. When you pass object reference pointer, now that becomes a little tricky. Yeah. So right. R equals to array pointer. Oh, you mean standard array pointer like that, right? You can do that actually. Yeah. So for example, standard vector integer and then a pointer and then a star. Then what happens is here the data type is a very custom data type, but still again a pointer. So here the data type becomes standard vector templatized int, okay, then a star, so as in a pointer. So it expects that data type. So what that actually means is B is storing an address, okay, but it stores an address to a custom data type, which is of standard vector integer. Yeah, so you can absolutely do that. You can have custom data type pointers and cast like that. So like when you say array, it has to be defined. So either as a class or in some namespace. So I'm assuming you mean like standard colon array or something like that. Then yes, those are already defined. You don't need to define them. You can access it. Yes. What will be the hierarchy there? I still do not get. Oh, you mean how can we cast one from other? Actually, you can cast anything to anything. When you do explicit casting, yeah. In custom classes, technically speaking, you can treat an integer pointer, then explicitly cast it to my base class, or let's say we saw some classes here, right? Base class pointer. You can. You can even cast it to derived pointer. Sure. But one has to be very careful here. While C++ allows you to cast one thing to anything, technically, you can't dereference them just like that. Okay. So when I say dereference, it's like trying to access data from it. So if a pointer was not originally, it's not even about losing data. It's about reading something which is just garbage. Why I say that is, let's say there was a function pointer. Okay. A function itself takes memory, right, in computer. You can derive a point, you can get its address wherever it's stored, right? And store it in a pointer. You can cast it to an integer pointer and then try reading 4 bytes of data. It won't mean anything, but you can still read it, okay? But it doesn't mean anything. Now, similar vein, if I talk about, so let's say this vector itself. So this vector object, okay, also has an address. You can get its address wherever this object is stored. I do not mean the vector data type. Okay. So standard vector integer A stores 10 values. Yes. So the actual values start at some pointer which you access by doing a.data. Okay. That is a different pointer. Okay. That is the pointer pointing to the actual values that your object A or C is storing. That is a.data. That is a different thing. So that's a collection of memory, right? Other than that, this class has other things. So it has size, it has capacity, it has other member functions of this object, right? All of these are also stored in some memory, right? So you can think of it like all of this memory, okay, whatever I've talked about, also sort of like you can think of it like there is a memory which I can use to access them, as in, so there's a starting point in a way, there's a starting point in which this object itself is stored. Okay, that address need not be the starting address of the values it stores. This is very important. You can typecast, sorry, you can typecast this A. So let's say there is an object and there's a address where this object starts, store it in some pointer, cast it to void, cast it to integer, cast it to anything. Let's say we cast it to integer because, well, because the values A stores is integer, right? Now, you might start reading 4 bytes chunks from it, but those 4 bytes need not be the same as the actual value it stores because they are not the same starting address. I hope this was not more confusing, but what I'm trying to get at is objects and variables themselves, when they are stored, they have some address which might be completely different than whatever the actual data structure is storing. So here we care about not the full data structure, where here when we try to dereference A, which is storing 10 values, we care about the actual values of the container, as in what is the actual values it stores, that starting address, not the whole object's starting address. Okay, you can definitely cast it. That's no problem. You can cast it like standard vector integer pointer also. But then the next question is asked is what are you going to do with that pointer? So one nice use case of this is, since it was asked, maybe I'll tell it. I'll just put it here. So for example, there is a class, okay, BE or something, and it has a member function. Okay, it has a member function, standard vector, let's say integer pointer B. Okay. Now, when I instantiate this class, okay, so let's say the object of B is class B. Okay. I have to use new and all, but think of it like this is already done. Then what I can do is access the object of, not, let's not call it B, but V. Access the so since this is a pointer, okay, okay, that's fine. Let's not keep it. Let's keep it simple. So there is a class. Then we define class B, updated at B. Okay. Then I access the object. Okay. Dot using dot, and then this V I want to resize. So I'll use the arrow operator, then resize to, let's say, 10. So what I did here is you can, so let's say there is a value you want to, so okay, let's say I want my class to have a certain member which is a standard vector integer. Okay. But the maybe this is the better example will be that will require. Anyway, that's okay. So let's say I want my class B to have a standard vector. Yes, here in this example, as you will see, you can always do a resize. But let's say I do not want for the. Did I lose? Yes. Okay. I'm audible again.
Yes, you are.
Okay. Yeah. Okay. So instead of storing the actual object, I want to just store the pointer to that object. Okay. That's what is happening here. So maybe I will have a different function, okay, which does something, but it returns a standard vector. Okay, let's say. So I can do it this way. B dot B equals to, now then store the address of that. So the return type of standard function, okay, is something like this. It's not a void function. It's more like this. Sorry, comment it. Yeah. And then there's some input or not or whatever, and there's some body of it. So this is one useful thing where, let's say, the function does something, or it could be another class also, whatever. That works with some standard vector and returns a standard vector. Then what you can do is take the address of that vector and then store it inside your custom made pointer. So now what happened is your object B doesn't store the actual vector, but a pointer to that vector. When I say pointer to that vector, I mean the pointer to that object. Okay, not the pointer to the starting address of V, which will be like V dot data or V arrow data or whatever. Here you'll use V arrow data to access the starting points, and then you can dereference, and then let's say ith element you can access this way. Okay, so this pointer data is different from this pointer that we are accessing or whatever address we're passing here. Okay, I hope the distinction is sort of clear. This is a slight example that also sometimes people use, where your class doesn't store the actual object, but it gets the object from somewhere. But to store that object, it doesn't store the object fully or like make a copy or anything. It just stores the pointer to that object. Okay, like this. Okay. Will that resizing affect our data? So you can, yeah. So now what happens is, since you're storing the pointer to that actual object that was passed, so that vector, okay, it is stored in memory somewhere. And let's assume that it doesn't go out of scope. Okay, this actually can introduce a lot of bugs, but let's assume that that vector still exists and it doesn't go out of scope or destroyed or anything. You can call v and then resize also to resize that actual vector. You can do this. Yeah, you can do that, and then give some number or something. Yeah. And is it like delegates? More like you're actually accessing that uh, vector through this arrow operation. You're accessing the members of that actual. So this is a little roundabout. I mean, not roundabout. It's like there's a lot of hops here, but I hope you get the idea. Standard vector integer pointer v stores a pointer. Okay, it's a pointer, so it stores an address where the dereferenced values are of data type standard vector. So you can now b.v is itself a pointer. So to access the member functions of that custom data type, you can use arrows. Yeah. Normally we would access, let's say if it was standard vector v without a pointer, then you would have done just v.resize v dot something. So let's say, for example, standard vector. Yeah. Awesome. Yeah, these concepts are little I know can be a little confusing at first, but the more you get used to this, these are all, so there is a certain rules and like there is an order to it, and all C++ is built on top of each other on that order. And there is a lot of freedom in which you can mix and match. So you can mix and match custom data types with, so these are inbuilt data types with custom data types like this. So after a certain point, you can think of this as also like some kind of, it's just some data type. It is just some data type. It's, but custom user defined, yes, but some data type. And when we try to cast something, it also is applicable for custom data types. Okay, they have their own certain syntax for doing things, but then again, this is yeah, it's not that different. So let's say there's another vector called a. So normally you would do a dot resize to access member variables. So this is an object of a class, standard some vector class, templatized vector class. We'll learn about templates later, but essentially it's member of a vector class. So to access members, you do dot. For same thing with, if it was a pointer, you just do arrow. That's all. Okay. Right. So yeah, coming back to this one, A is a C style array. Okay. And P is integer pointer. Now the good thing about C style arrays is that the A itself is a pointer, as in to access this data, one normally writes loops like this, right? So or loop, then integer I starts with 0, less than the size of the thing, which is 10 here, and then increment that I. So to access, one uses the bracket operation. Remember, this is also a dereference operator. Okay, so to access, you do this, or so question is, okay, maybe I'll just finish this and then get back there. So remember this and this are the same thing. So what you are doing is, starting from address A, you increment I, right? And then using the star, you dereference it. This bracket operation is basically a shorthand representation of this. Okay, so essentially what you're doing is you are pointing whatever A is storing as the address, we're storing it in P. Okay, and in this line. So this is allowed, this is fine. But if you see this line, there is an integer pointer and some address, okay? And you're overwriting A, which is already which has allocated some data again. So this is an error. You it's not even about simple typecasting or anything. This is overwriting memory itself. Okay. So here the problem then, if you think about it, what happens is you have allocated memory. Okay. This is the memory. The starting address to that is A. Okay. And if you override that address, whatever this guy is storing, nobody has access to that memory, right? No variable in this program has access to the memory. It wasn't freed. So dangling pointers. Okay. So that's a no. So this is not allowed. Okay. That's the error. Okay. All right. Then okay, question. So you want to dereference a pointer, then we'll use arrow, right? No, that's not exactly correct. Dereferencing a pointer is always this, whatever I'm showing here. So A is a pointer. You can do pointer arithmetic as in shift how much you want. So this number is 1 to in units of 1, like I goes from 1 to some 0 to 10 or something, right? So in units of 0, 1, 2, 3, or 4, you move your pointer, but how many bytes, that is decided by the data type of thing. So A is integer data type. So this will move in units of 4 bytes like that. So that is automatically decided by the compiler during runtime. I mean, your OS will figure that out. So, and compiler also knows, it tells that this is an integer data type. So whenever it moves by some units, it will be of this many bytes. Okay. When we say dereference operator is always the star operator. Okay. So when you say dereference using arrows, you are accessing your, yes, certainly you're dereferencing it. I won't deny, I won't disagree also. But when you're accessing the arrow operator, you're dereferencing the actual object and then doing a dot operation as in accessing a member. So an arrow operation is a combination of both dereference and accessing the member functions, member variable. So if I use double, then it will skip one iteration. So in this example, when you want to use double, it won't skip on iteration. It will skip for instead of 4 bytes, it will skip 8 bytes. If you have casted A to be, let's say you cast A to be double integer, double pointer. So currently A is integer pointer. Okay. So which is of size 4 bytes. So 10 elements are there. Yes. Each 4 bytes. So A has 40 bytes of data. Correct. But if you cast, if I store if I store D equals to then double pointer A, okay, I cast A as a double pointer and store that address into D. So since Q, since Q is a double pointer, then if I do D plus I, okay, I can't do 10 because then I'll overshoot. I can do till 5. Yeah. So then it will treat those 8-byte units as some numbers. Those numbers could be garbage or there'll be some values, but you can treat them as 8-byte doubles and then read them. Okay. You won't exactly skip iterations. It's more like your iterations will get halved because you're going in, instead of 4-byte units, you'll be going now in 8-byte units. Okay, that one. So the arrow operation, okay, like I was saying before, dereferencing is always with the star operator. Okay. So A is a pointer, yes. And you can do pointer arithmetic. that's fine. It can be 0 also. So it will essentially be A itself. So the star operation will dereference it, as in access the value at that location. Okay. So if you think about it, V here is a pointer, yes, of standard vector type, standard vector integer. Okay. So when you think about star, means it will act. Okay. So you can actually do this also. So here you defined as something called A. Okay. Then I dereference V. So whatever standard vector it was pointing to, I dereference and then store it in A. This will be a copy construction. But for now, just think of it like the same vector now gets copied into A. Okay. When I say from V, I want to access. So all of these are referring to, okay, let me do it this way. So standard vector V, okay, and then here there's a function. Hmm. So, okay, let's do this way. Return original vector. So this is the original vector. Oh, sorry. This is the original vector that is being moved around, passed around. We're doing all sorts of things with this. This is the original guy. Okay, so its data type is standard vector, this some function, and end of the day, we're returning it. Okay. Now this function, okay, it's it has some address. That address is stored inside V. Okay, so since V is a standard vector pointer, so it stores an address. Okay, and that address is pointing to the original vector. Now, if I dereference V, I'll get this original vector, which will get returned here. Okay, and then it will make a copy to A. Fine. But what if from the pointer itself, I have to access the members of original vector? So it has members like data, resize, and so on. To access members, one does dot operation, right? So we do a dot resize. Like here, if you think about this one, this is a simple standard vector, no pointer business, nothing. To access its members, we do dot operation and then access the member function, right? So this arrow operation, okay, is a combination of star operation where a dereferencing the vector, okay, which is the original vector, and this is a very bad way of writing it, but you can think of it like first a star operation and then the dot operation. This is what arrow operation is. Okay. So this resize is equivalent to original vector dot resize. Here, this is equivalent to original vector dot data and then I, which is also equivalent to original vector bracket I. Okay. Which is also equivalent to, you can write it this way. Yeah. So this bracket is just a placeholder. Yeah. The actual code is this. Yeah, from here to here. So all these are equivalent. So this question is, we can say like where a member function of a class is referencing from outside our main. You can say where a member function of a class is referencing from outside of main. Actually, from anywhere. It need not be from outside or main. Yeah, correct. So if you're trying to access a member of an object here, V is so original vector is an object, okay, of vector class. I want to access its member functions, but strangely, I have only access to B. This function comes from some external library. Let's say you don't have any access, you just have access to that standard vector. Okay. And let's say your code is written such that it can only store the pointer to that vector for some reason, let's say. Now, this function v, we will store the address of whatever it returns. Okay, so the address of the object is what we're storing. To access its members, we're using the arrow operation, which is a combination of dereferencing the object. That means I'm actually accessing the original vector. That's what dereferencing is. Then I'm doing a dot, okay, to access its members. The combination of both is essentially the arrow operation. To access private members, not necessarily. Public members, yes. Private members you can't access outside the class. Yeah. So when we do arrow operation like this, we are accessing in some kind of a public, like in main or in some other function outside the object, right? So not private members, but public members, or depending on situations, protected members also. It depends on where you're accessing, but yes, sort of the idea. Private also you can't access in derived classes. Protected, yes. Private members of base class you can't access in derived class, but private members of the same derived class you can. Yeah. Hence the this operation that we saw before. There should be somewhere. Yeah, this one. So inside the function, the pointer to that object is this operation, as in this THIS. So its data type is my class pointer. When we see this one, as in this, then you use arrow to access X. It can do this because every class has access to its own private members. So you can access X like this, like write X equal to A, or you can write this arrow X and then equals to A. This is also valid. Yep. It just gets little getting used to. Like I was saying, the rules are very well defined, and you can think of it like there are maybe a lot of rules. Yes, maybe 100 rules, but you can take any combination of these rules and then write code. That's what essentially happens. We have public members, we have private members. On top of that, there could be variables, there could be functions, there are pointers, and there are const data types and non-const, like that. So all these combinations you can put in any combination or on top of each other and then just write code. Like I showed this example. Here it's essentially, I'm not defining the actual vector, but getting that vector from some function, okay, whose data type is standard vector integer. I'm storing the object's address in my variable called v, and then accessing the original vector's members using the arrow operation. That's all. That's all what I'm doing. Okay. So you can think of arrow operation is sort of like a dereference and a dot operation. Okay. Right. Since we're almost out of time, I think you can take questions and then close the class later.
So, sir,
Hmm.
a pointer, a void pointer can hold address of an integer variable. Is it?
So when when I say one says a void pointer, it just means that, let's say void pointer R, right? Here we had R. So I have defined R as a variable. That variable can always store numbers. Okay.
Okay.
So it can point to technically anything.
Okay.
Okay. Now what we are saying with void pointer R is, I don't know the data type of that the value that the address stores. So I have a variable R which stores some address here, and that address stores some value. Okay. Now that value, is it of integer? Is it custom data type, my class, or what is it? I have no idea.
Okay.
That's what the void says.
Okay.
So
So
technically, you can treat that value by, this is what typecasting does. You can treat by here, that's what is happening here. So I will treat that pointer as an integer pointer, which means that value that I was referring to, which I had no idea about, I'm going to treat it as an integer and access those values through P.
okay.
By dereferencing P, now you will get integers. I mean, that's the
Okay.
hope. Yeah. Yeah. And then that's the hope. But
Okay.
you might run into issues if you have not allocated memory, or you're trying to access memory which is not there yet, like that. So here we haven't allocated memory yet. We just defined pointers saying that it can store some address. Great. Here it actually stores an address because there is an integer I. So I has some address and it stores I. And that's how we are able to set P to something. And if you try to print P, you won't run into issues because it is actually storing some address. But here, since I've declared just void pointer R might not, R will, it's just declared. It probably is given some address. Yes, maybe. If you try to print R also, might get some garbage like that. So it becomes very important to be clear in dealing with pointers. The main problem happens when you do out of bound access, and that usually happens when you don't know how much memory is you're allowed to access, right?
Okay.
So that is one issue. Second issue is when one has forgotten to allocate memory. So like here we haven't allocated any memory. So if I try to dereference R, like let's say in this case, I casted R to treat the values as an integer. Amazing, awesome, and set it to P, which overrides this original P, which actually had some valid address. Now
Okay.
it is storing some address to some value, but that value doesn't exist. I mean, there is no actual memory allocated to it. So if you try to dereference P and access those integers, you just run into all sorts of segmentation faults. Okay. So yeah, one has to be careful while dealing with pointers. Pointers at first seem a little confusing, but once you get hang of it, it's just the same rule. It just stores an address to some value, and that value's data type is determined by the type of the pointer. Okay. And that value should be allocated. If the compiler hasn't allocated or the user hasn't allocated, OS will just throw errors. It freaks out when it sees that you're accessing data you should not be accessing. That's all segmentation faults is.
Okay. So the void pointer can be used to allocate memory. Like in C, there was malloc, calloc, and other things.
Right.
So the thing is that let's say user allocates some memory for integer, right? So we need an integer pointer to hold that. For double, we need double. But in the
Right.
case of void pointer, it can store anything.
No,
So
that's the thing. Your integer pointer. So let's say you used malloc to get 4 or let's say 16 bytes of integers.
right,
Okay, so it will return you an integer pointer
right.
because you're saying to the malloc function that I want this much data and I want them to be like integers. Okay, like integers, so 4 bytes and so on. You can cast it to be void also.
Okay.
Okay, it is absolutely okay. You can treat it, you can play around with addresses, the value the address store like anything. You can treat it as later on, you feel like, oh no, I just feel like treating them like double. Sure, you can do that and then access them in 8 bytes. So the end of the day, the point is there is a certain memory that has been allocated, certain bytes. How do I want to treat from the starting point? It's completely up to me. Completely. That's all.
Okay.
Integer pointer just means that I'm treating the values as 4-byte units and integers, specifically integers. If I
Okay.
treat them as float, they're also 4 bytes. Now here's the distinction. They're also 4 bytes, but they're treated as float rules, not integer rules. That's it.
So as per requirement, right?
Yeah, sure.
Thank you, sir.
So question is, we use NVIDIA. So my question is, for CPU, do we use assembly language? So actually what happens is, end of the day, your Python code, C, C++, Java, any of them, all of them are compiled into assembly language. I mean, as in there is an intermediary. Then assembly language is essentially the 64-bit or 32-bit architecture instructions. So it could be x86, so that is 32-bit instruction, x86 64, the 64-bit instructions. The ARM instructions also 32-bit and 64-bit. So the x86 and x86 64, those are CISC, as in complex instruction sets. You have reduced instruction sets, RISC architectures. Those are 32-bit. Yeah, I think back again. Yeah, okay. So all of these instructions are there in assembly language. Yes. So there are so many which should I learn in assembly. That's okay. I would say I'm not the ideal person to ask because I do not write code in assembly. Also, to most programmers out there, like I would say probably 99.9% programmers, I would suggest not to even write in assembly because you write simple code in C or C++, the compiler is going to generate assembly code, which is probably um, very much more optimized than what you can even write in most cases. So people just usually leave the assembly code to compilers. Yes, there are cases. I'm not denying this. Yes, there are cases where some part of the code people write in assembly because those guys are the ones who can. And so it's like even the most optimization level, like even the most lowest level of optimization, they don't want to leave on the table, squeezing even the last juice of yeah, I mean, it's a very good goal though. I would definitely encourage, but something for most people, I do not. I mean, if you are interested, then definitely go for it. But yeah, it's like, so even the last juice of performance, they do not want to leave on the table. That's when people write assembly. Yeah. Even CUDA has assembly. Yeah, it's PTX.
Sir, general question.
Sure.
In CPP, is there an end to learning CPP? Means in
Yeah,
the sense.
yeah. I mean, honestly, it's a very vast language in itself. So you can make courses out of it, right? So
Mm,
this is like advanced CPP. So it's in itself, it's also like a huge course.
mm,
Um, what I would suggest is understand the basics and some of the new modern features that this course covers. I would say that's
mm,
more or less it. For most general cases, that's fine, as
fine.
in
Okay.
understanding and learning. Certain topics, I would say, if you encounter them, learn on the fly.
Okay.
Because yes, there are certain topics you might not cover in, I mean, even in advanced C++.
Mm,
So I don't want to scare you, but you can actually go ahead and someday take a look at this header files. So these header files are um, like from GCC or whatever compiler you like, Clang or
mhm,
MSDC or anything. They have their own, so that written by these developers, right? So they have their own implementation of IOStream.
mm,
Each compiler has their own. So you can take a look. It'll look very scary,
mm,
but maybe not now. So, but
yeah.
to understand what each of the line means and something, that itself you can just learn on the fly. Okay, what is this line and how does this happen? You can take a uh,
Mm,
on the fly chance at it like that.
mm,
But yes, one way I would say is you can. I mean, that's like one of the production level code that is like, okay, this is something I want to understand. As in, if I look at C++ code, the most horrific or horrible looking code is probably something like this. So if you can understand that, probably you can understand every C++ code out there. So maybe
mm.
that's the goal. Yeah,
That's good.
right.
So, one more question aligned with this, if I may ask.
Mhm. Go ahead, go
Uh,
ahead.
so the question is, the developers, the original developers of CPP,
Mhm.
did they write this much complex of IO stream, or later it was developed in such a stage?
Right. So the way it goes is, um, so there is something called ISO C++, as in this is more of a standard. Okay.
Mhm.
Think of it like there are rules your standard has to follow. As a standard C++, let's say 11 or 17. Every time the new version of the standard comes out, it's just given a new number. Like C++, 11, 17, 14, 17. Every 3 years, there's a new standard, 20, 23,
Okay.
and so on. So 26 next year, there will be another standard. So
Mm.
this has a set of rules. And every year, more rules are added. Okay. And some things are deprecated. That's
Mhm.
how the standard evolves. Now,
Okay.
uh, compiler, let's say like GCC, which supports a certain standard. So let's say standard C++ 11, certain version of the compiler will support that. So let's say GCC 11. Okay.
Mm.
So GCC 11, let's say supports C++ 11 standard. It means that GCC 11 follows all the rules defined in
Mm.
that standard to make this code, this file. That's all.
Okay. Mm.
How does the code look? It doesn't matter. As in, it is completely up to the developers. They can do all sorts of horrible looking optimization. Absolutely okay. Standard doesn't care. Standard does just defines certain rules. As long as those rules are followed, it's all good. Hence, sometimes if you see certain code, it depends. Again, it's a certain code are more are faster if you use certain compilers.
Mm.
So if you use certain compilers, let's say Intel compilers on Intel CPUs,
Mm.
okay, and maybe not some other compilers will not give you the same performance. Again, there are nuances here. You can pass certain flags to compilers to get those optimizations, but it is possible. I'm not saying it's always the case, but it is possible that Intel compilers might give you more performance on their Intel CPUs. And maybe AMD compilers can give you more performance on their CPUs, like that. I mean, it's just an example I'm giving. Yeah,
Okay.
yeah.
So we can actually enhance CPP for our own selves, like our own
Yes,
custom
you
library.
can.
Nice.
That's exactly the um,
Just.
what do you call the motive behind classes. You
Mm.
can define like anything. I mean, you can start with a class, write your own stuff, fill the whole thing, and make another vector class. Let's say you can absolutely do that.
There is overloading, operator overloading, which also
Yes.
enhances that.
Yeah.
Mm. Right. I've seen. Thank
Yes.
you.
Yes. Yes. Sure. That's the question. Which one should I learn? Oh, in assembly. I mean, it depends what programmer you want to be. So there is a very low level embedded C people do. So if you're interested in very low power devices, then you can probably learn embedded C and all the assembly that goes in there. If you want to become a GPU programmer, then you can learn CUDA. You can learn about PTX. So PTX is the assembly language of CUDA. Yeah, you can go ahead any direction. Oh, okay, awesome. CUDA, well, thing about CUDA is, yeah, um, right. So thing about CUDA is you can write kernels, you can optimize things. I mean, honestly, the best way to learn CUDA is just read their documentation. There is probably nothing more comprehensive than their documentation. Yeah.
Sir, here in line 15 and 16,
Mhm.
you have assigned in line 15 and 16.
Right.
If we see out Q and P, will they
Mhm.
point to same location?
Right. Okay. So if I enable these two, right?
Yeah.
So let's say I enable these two. P originally had some address. We treat it as double pointer and then store it in Q. Okay. Now then use that same Q, um, typecast it and store it in P. Yes. So your question is, will they give the same address, right?
Yeah.
Yes, they will.
And if we dereference them and then see out,
If no, sorry,
if we see out star P and star Q,
star P and star Q, then we'll run into probably errors. Let's see. We should not, because P has allocation. Yeah, we can actually. Let's print. But for this one, we might actually run into issues because we're treating it as a double pointer. Here it is only 4 bytes accessible. I'll probably run into set fault. And yeah, I mean, it might not actually, but this is an error. When I say
Okay.
it might not run into segmentation fault, because sometimes when you access a certain little extra memory, okay, it's actually the memory of the program. So the runtime doesn't throw errors. This is a very bad bug which stays and very hard to debug, but let's see. So, sorry. So we'll just print Q first, then P.
Here, let's comment out the line 16 first.
Okay.
Just Q is equal to double P.
Okay. P is from originally here, and Q has been casted. So let's see this. So yeah, Q we print it as like we're getting that address from P. So that is this address. This is an hex. So just for the whole audience, this is a representation of you can think of it like a positive number. Instead of base 10, we're using hexadecimal representation to represent positive integer number. Okay. So the P is also the same, like what we're saying. Right. But let's say
Now,
we do
if we star P and star Q in the same part.
the same, yeah. Star, yeah. Actually, this should throw errors, but let's see. It printed something, sure. So as we see, what here happened here was P, it took the address, okay? It took the address from P, then accessed 4 extra bytes. So the first 4 bytes actually has ones and zeros corresponding to 5. So 5 is in decimal. So if I convert it into 32-bit representation, it will have ones and zeros. So that ones and zeros, when treated as integer by P, so star P, that gave me 5. That's fine. But the next 4 bytes, 32 bits, also has zeros and ones. Okay, in the program, it exists. Let's just assume it exists for now. If I try to read a combined 64-bit and then treat it as double, okay, because this is a double pointer, that number is this guy. Okay. It is this like some -7 or some garbage looking number. The reason is we actually haven't allocated memory. I mean, this is actually not correct also, because we have just accessed it and reading it, it is okay. But if you try to overwrite it, you might write parts of your code that was allocated memory. So this whole program has some memory allocation, right? So as long as we don't go out of that program's memory allocation, this won't actually throw error. And 4 bytes is very small. So we have like 10 bytes, like 40 bytes here and some other few bytes. So yeah.
Okay. So here in line 15 we have upcasted, and now if we downcast, we'll same get a garbage value.
Line 15 you have upcasted. Yes, correct. So if you
If
you downcast it, it's essentially like I had 8 bytes to store something, and I'm using 4 bytes. And let's say I'm treating it as integers. So let's say originally I had double, right? And I'm treating it as 4 bytes integer. Then it will just store a less precision number. That's all. It will still give you a valid number though. Yeah, it'll give you some data, I mean some number, but just less precise.
Okay, got it. Thank you.
Okay, awesome. I guess we can end the class now. All right. Again, I hope you guys enjoyed today's class. Do practice, and you can ask questions in the forums also. And happy coding.
Okay. Thank you, sir.
Thank you.
Thank you. Thank you, everyone.